Hello chat, welcome back to another video. In this video, I'll be showcasing the small factory game prototype that GL2 is working on. It is a very simple and bare bones prototype at the moment, but we'll expand on the idea and polish it if we find it interesting enough. It's taking inspiration from other factory-like games that we have played before, like Satisfactory, Factorio, and especially Minecraft tech mods, like GregTech and Create. First, let's talk about the power system. The power system in this prototype is implemented using poles and wires, like Satisfactory's. You can place down these poles and connect them using wires. Internally, these are represented by vertices and edges in a graph, allowing us to use graph traversal techniques like breadth first search and depth first search. Here is a simple generator that can indefinitely generate power. If you peek into the UI panel, you will notice that it can generate up to 10 units of power, indicated by the denominator of this fraction. This means that this generator can supply up to 10 units of power to connected machines or consumers, but currently it isn't connected to anything, so its load is 0. Let's change that by connecting the generator to this battery, which will request power from the generator. As you can see from the smoke particles, the generator is in fact doing something. If we look into the UI again, you will see that we are using 10 out of 10 units, which means that this generator is at peak usage. The battery, however, is unfortunately not getting enough power as its charge rate requires 20 units instead of 10. There isn't a negative side effect to this other than the fact that the battery is not charging at the rated speed. We can fix this by connecting this wind turbine to the battery as well. If we check the battery UI again, you will notice that it is being charged up at the required rate of 20. You can see that the charge percentage is increasing as well as the remaining time value. This value indicates how much time the battery could power machines that are connected to its output pole. This doesn't matter right now, as we have nothing connected, but if you have some sort of power backup system, this could let you know how much time you have until your network shuts down. You might have noticed that the flow of energy, indicated by the animated arrows on the wires, is taking the path from the wind turbine to the battery instead of using the generators. This is because the wind turbine has a higher priority than the generators, so any requested load on the network will be first taken off from the wind turbine, which has a priority of 50 compared to the generator's priority of 10. This allows the factory to efficiently use renewable energy first, like turbines and solar panels, before using non-renewable energy like coal generators or combustion generators. This also helps if you want to utilize the energy of your generators before fallbacking to battery power if you have any. Like GregTech, the wires have a rated maximum load that can safely pass through them. If the wire transfers more load than it is rated for, it will start getting hot, burn, and eventually disconnect. The current wires have a max rated load of 20 units, so if we try to power things that take in more than 20 units, the wire will burn down, just like this. The current state of the wire is burnt, but at the moment there isn't a visual or auditory indicator to let you know. Also, you can't repair or cut wires yet, so you're kinda screwed unless you make another path for energy to flow. There are currently 5 types of generators. Generators. These can generate power indefinitely, currently just for testing purposes. Wind turbines. The wind turbine's output fluctuates based on wind, so sometimes it can be as low as 0 units or as high as 50 units of power, depending on the wind. Currently, the wind is a simplistic, continuous, simplex noise function based on time. Solar panels. It is another renewable energy source, but power fluctuates depending on the time of day. There are 2 types of solar panels, fixed and dynamic. Fixed solar panels always have a fixed hinge, whilst dynamic solar panels actively rotate their hinge to match the sun's altitude for optimal power generation. Only one axis of rotation is implemented, so this does not take account the azimuth of the sun rotation. Batteries. Batteries must be charged up before use, and they store power for later use. These are helpful when you can generate an excess of power but don't want it to go to waste. Supercapacitors. Supercapacitors are just like batteries, but with a much higher charge and discharge rate at the cost of lower capacity. Handy if you need to smoothen out power fluctuations along your network. Anyways, onto the item system now. In our implementation, items are implemented using item stacks, like in Minecraft. Each item stack takes up 1 item slot in I/O buses, but you can have up to 256 items per stack, count subjects to change. Each item bus currently has 1 slot, but we will implement multi-slot buses later. This pink cuboid is a chest. It has 1 item slot, and it currently holds the maximum number of iron ore. We can connect this chest to this machine over here that takes in iron ore, as you can see from the recipe. It will take in 1 iron ore and convert it to 2 iron ingots. It is basically a rudimentary smelter. When we connected the chest to the machine, you will notice these cylinders moving on top of the conveyor belt, which is yet another cuboid. These cylinders are the iron ore stacks, and each stack contains 16 units at the moment, since that is the transfer rate of the conveyor belt. Currently, the machine is not doing anything. You can see this halt reason attribute that tells you why the machine is halted, and it states that it is lacking power. This makes sense because the power pole of the machine is not connected to anything, so let's connect it to one of the generators. There are smoke particles coming out of the machine, letting us know that it is processing a recipe. If we check the UI, you will notice that the iron ore that we have put in is being transformed into iron ingots with a 1:2 ratio. Currently, you can't do anything with these items other than look at them, but eventually we will implement a crafting system with resource management. Another cool thing we can do is add a chest next to the machine's output, and connect the two using another belt. You will now see that the new iron ingots, which have a cube model, are now being transferred to the chest, which is very cool. That is all for this video. We hope that you found it interesting. Thanks for watching.